Myself S.K. Sharma from Kendriya Vidyalaya, Aligarh. Now my topic is grouping of resistance. There are two types of grouping of resistance: series grouping and parallel grouping of resistance. Now I want to start series grouping of resistance. Suppose there are three resistance R1, R2 and R3. These three resistors are connected in series and there is a source of EMF of battery V volt. So because these three resistors are in series, so the current is same in all these resistances, while the potentials are V1, V2 and V3 respectively. Now potential drop across resistance R1. V1 is equal to IR1. Similarly, potential difference across R2 and potential difference across R3, V3 is equal to IR. Now, net potential difference V is equal to V1 plus V2 plus V3. Net potential difference between X and Y here. So I is taken common here, R1 plus R2 plus R3. If we replace these three resistance by an equivalent resistance of capital R, so V is equal to IR. Now compare these two equations. IR is equal to I R1 plus R2 plus R3. So I cancel. R is equal to R1 plus R2 plus R3. This is the expression for series grouping of resistance. Now, number 2, parallel grouping of resistance. Now we can again assume three resistance R1, second one is R2, third one is R3, R1, R2, R3. These three are connected in parallel with a source of EMF of V volt and with the help of a key. Now current in the circuit is I. Suppose the current in R1 is I1, I2 and I3 here, while the potential in parallel is same, equal potential in parallel, while the current is divided in series resistance. So, current in R1 resistance, I1 is equal to V upon R. So V is common, R1. In the similarly, current in resistance R2, I2 is equal to V up by R2. Current in R3, I3 is equal to V by R3. Now the net current in circuit, I is equal to I1 plus I2 plus I3. V is taken common here, 1 upon R1 plus 1 upon R2 plus 1 upon R3. Equation number 5. Now if we replace these three resistance by an equivalent resistance capital R, if we replace these three resistance by equivalent resistance capital R, so I is equal to V by R. Then from first, V by R is equal to V is taken common, 1 upon R1, 1 upon R2, 1 upon R3, cancel, 1 upon R is equal to 1 upon R1 plus 1 by R2 plus 1 by R3. Now this is the expression for parallel grouping of resistance. Hence it is clear, if we connect two or more resistance in series, then the effective value is greater, and if we connect two or more resistance in series, then the effective value is less. So, the net resistance in series combination is more than compared to the parallel combinations. Okay. If we have only two resistance in parallel, note, if we have only two resistances in parallel, R1, R2, then we can simply solve resistance in parallel combination R1 into R2 by R1 plus R2 directly. And for the more than two resistance, we will apply this formula. Yes? Okay. Okay. Now the